Thank you for taking the time to watch this video. This is Yajie from University of York. This work was finished by me, Nick, and Hao. Here I will introduce the quick overview of our paper, Adversarial 3D Face Disentanglement of Identity and Expression. There are many applications. They all rely on a good disentanglement of identity and expression, and it helps to understand 3D facial images from the shape. So, based on this purpose, we proposed a new framework for 3D face identity and expression disentanglement. Some related work already did the 3D face disentanglement work. We would like to introduce two work. The first one, Mesh Encoder, is Zhang's work. They proposed a distribution independence-based method to learn to decompose 3D face hair. This method aims to eliminate correlation of the identity and expression distributions. The second one is Zhang's work. They used two branches in the decomposition part, one for expression extraction and the other for identity extraction. However, this related work has their own limitations. They all used neutral faces as their identity face to achieve this entanglement. But in the reality, sometimes the neutral faces are not able to be obtained. We try to disentangle identity and expressions from this point of view. This is the main difference from our method. So, if we don't know the neutral ground truth, how can we reach the disentanglement goal? We propose an end-to-end network using an adversarial approach. It combines a point-net-based variational autoencoder and a discriminator. So, this is our architecture. We have one encoder and two decoders for human face reconstructions. We input a 3D human face, and we have two decoders, one for ID and one for expressions. The ID part will output the predicted identity, and the expression part will output the predicted expressions, and they have their own latent code, ZID and Z expressions. And combine the XID and X expressions, we get the final 3D human face. We have another identity discriminator, and we will introduce it in details later. Our inspiration of the identity discriminator came from Stellar's work. FC is the root of all expressions. They showed that the center of expression space is the point of FC, where all face muscles are relaxed. Based on these observations, the implicit connection of faces with the same identity is the FC expression. Our adversarial process encourages common information from a face shape pair with the same identity to be retained. When neutral ground truths are unknown, we can leverage the invariance of identities from same individuals and use the FC expression as the center of the expression space in order to train our model. The identity discriminator is trained to distinguish between real and fake samples. We input a 3D face shape pair into the identity discriminator that decides whether the input pair has the same identity shape. For instance, if we input a face scan pair AI and AJ with same identity AID, this identity discriminator is expected to classify this pair into the real class. Otherwise, A pair AI and BI should be classified into the fake class due to one with the identity AID and another with the identity BID. This is a binary classifier that determines if two input faces are from the same identity and encourages the predicted identity face to have the same identity features as the input face. There are several shaped pairs from the same identity, and their expressions intersect at the point of Fc, so the discriminator will finally return all pairs common information, Fc. In our network, after finish the pre-train process of the identity discriminator for the joint training process, the ideal situation is that predicted face identity shapes from the VAE can fool the discriminator. In other words, the predicted neutral face shapes are close enough to the corresponding facial identities to make the discriminator believe that they belong to the real class. So, look at our experimental results. The first row is our ground truth. The second is our predicted. The first column is the full face. The second column is the neutral face. The third column is the expressions face. So when neutral ground truths are known, our predicted neutral face and our predicted expressions face are good enough. In our other experimental results, we can see for those without neutral ground truth, if our identity discriminator being used, the disentanglement error decreases significantly. If the neutral ground truths are known, it's a strong supervision training process. In contrast, the VAE and the discriminator learn identity representations in a weakly supervised process. So, when ground truth neutrals works, the effectiveness of weakly supervised process is not obvious. So look at these results. If identity discriminator not used and the neutral ground truth not used, the predicted neutral face and the expressions face are as the pictures.